Means measurement of straightness, measurement of roundness. Now, first of all, we should know what is straightness. Basically, straightness is a geometrical shape, and geometrical tolerances for straightness will be specified with straightness to be attained while manufacturing. Now, what is straight? A line is said to be straight over a given length if the line is contained between two imaginary lines that are placed at equidistance from the geometrically ideal position of the line being tested for straightness. The distance between the two imaginary lines is to be equal to the specified straightness tolerance. Now in this figure we can see that the center line, which is marked as geometrically ideal line, and the two parallel lines above and below this line is being used for the tolerances. Now we can easily see that the highest point on actual line and lowest point on the actual line, the distance between these two is called as the straightness error. So a straightness error of a line is defined as the distance between two lines drawn parallel to geometrically ideal lines, such that one of the two lines passes through the highest point on the actual line and the other line passes through the lowest point on the actual line. How can we measure straightness? So there are following instruments available for measuring the straightness. Now first one is straight edge, second is spirit level, and third is autocollimator. Now what is straight edge? It is a flat length of tool steel that is ground to extremely fine tolerances along its shapes as shown in figure. These are available from 30 cm to 60 cm sizes. They are used to check surface for straightness. They are also used to scribe accurate straight lines. Now how should we use how should we use straight edges? The method one is place the straight edge on the surface to be tested and determining the degree of contact by marking filler or light gap, as done in the case of tri-square. Suppose now we are supposing that the light is used. The gap between the straight edge and the surface will be negligible for perfectly straight surfaces. It is measured by observing the color of light by diffraction while passing through the small gap between the straight edge and the surface. If the color of light is red, it indicates certain gap in millimeter. Similarly, if the color is violet, then the gap will be less. Similarly, there is another method in which straight edge is supported at 2 points for minimum deflection on two unequal piles of slip gauges, such that it is at a slight inclination to the surface to be tested, as shown in figure. Okay. Now we'll divide the distance between the supports into number of equal parts and mark them on the straight edge. If the surface and straight edge are perfectly straight, the gap at each point will also vary uniformly, as you can see. If the slip gauges used have values 5 mm and 5.1 mm as shown in figure, and if the distance between the slip values are divided into 5 equal parts, then the gap at each point will vary from 0.02 mm, that is 0.1 upon 5. Hence the value of pile of slip gauges required at position are: first position 5 mm, second position 5.02, third position 5.04 mm, and so on. Now when the slip gauges are inserted at the marked position, one of the following two conditions occur. Okay. If slip gauges make exact contact with both the surfaces at the marked position, there is no error in slightness. Okay. If slip gauges don't fit exactly at the marked position, means there is error in straightness and displayed along the straight edge by amount proportional to the errors. Now in this series, the second method is spirit level. It is a very old method. The straightness of a surface to any length can be tested along a spirit level. This method has a high degree of accuracy. This is also measures small angular displacements relative to a horizontal datum, the level of liquid at rest. Straightness is checked using a spirit level as follows. A straight line is drawn, that is the datum is drawn on the surface whose straightness is to be checked. Now a spirit level with 2 feet as shown in figure is moved along this line in steps. For each position the reading is noted, that is variation in bubble position represents angular displacement in the surface. Now it is very important to note that the spirit level is moved such that the length of each section is equal to the distance between center lines of the 2 feet. Okay. Now spirit level has a limitation that it can be used only for measurement of straightness of horizontal surfaces. It cannot be used on vertical surfaces. Now next is autocollimator. Now this method has a very high degree of accuracy, and it can also be used on vertical sides as in case of horizontal slides. It has a converging lens with a point source of light at its principal focus so that it can emit parallel light. When a parallel beam of light is projected from this lens, and if a plane refractor is kept at 90 degree to the beam of light, the light will be reflected back along its own path and will be brought to focus at the same position as that of the light source. Means you will be getting the image at the same position where the object is placed. Now, if the reflector is tilted by an angle theta, the parallel beam of light will be deflected by twice the angle, as we know by the principle of optics, and be brought to focus in the same plane as a light source but to one side of it. Means in this case the image and object will not coincide but will be placed at a distance of 2 times of focal distance into angle, focal distance of the lens. Okay. Now this method of testing straightness consists of placing a block fitted with a feet at convenient of distance apart and carries a plane reflector. This arrangement is moved along the line to be tested for straightness in equal steps. Angular variation at each position is noted and used to plot the graph of error as shown in figure. So I think this method is clear to all of you. Now next is flatness testing. Now one way of testing flatness is to compare the surface with an accurate surface, which is called as geometrically ideal surface. Okay. If the test surface is small in size, then it is rubbed against an accurate surface that is evenly covered with Prussian blue color paste. If this distribution of color over the test surface gives an idea of peaks and valleys on the surface, means if distribution is uniform, then you will not be getting any peak and valleys. But if distribution is non-uniform, then we can easily understand that there are peaks and valleys on the surface. And by the quantum of non-uniformity, we can easily check the flatness. Now, if the test surface is large, then this method cannot be used. Then a spirit level and autocollimator is to be used. Okay, flatness error is indicated in microns or millimeters. The next in this series is, that is informed measurement, is roundness measurement. Roundness is also known as circularity. By definition, roundness or circularity is the radial uniformity of work surface which is measured from the center line of the workpiece. It is conform to the definition of the circle. What is circle? Circle is a locus of a fixed point moving in a fixed distance, okay, which is called radius. It is, this roundness measurement is specified by circularity tolerance. For example, if it is specified that circularity of a feature to be 0.1 millimeter, then it means that the circumference of each cross section of the feature should be contained between two coplanar concentric circles that are 0.1 millimeter apart as shown in figure. Error in roundness is defined as the radial distance between the minimum inscribing circle and the maximum inscribing circle that contain the actual profile of the surface at a section perpendicular to the axis of rotation. Now, how can we measure roundness? There are two methods, V block and dial indicator method, and second one is roundness measuring machine. In V block and dial indicator method, it consists of a V block that is placed on the surface plate, which is very precise. The workpiece to be tested is placed in the V groove of the V block shown in the figure. Now, the feeler of a sensitive dial indicator held firmly by a stand is made to rest on the workpiece. Now the workpiece is rotated about the diameter to be checked. The dial indicator will indicate variation in the dimension and cause due to out of roundness. Now there is another method using same V block and dial indicator. It is plotting a polar graph. Okay. What we want actual shape of the workpiece, which can be obtained by plotting a polar graph. Now 12 equispaced marking at an angle of 30 degree are made in the face of the workpiece to be measured. Now the workpiece is placed on the V block. The dial indicator is made to touch the workpiece at its center. Now when the workpiece is rotated and when the marking comes exactly under the plunger of the dial indicator, the reading is noted. Hence we will be having 12 readings. Now this procedure is repeated thrice to get average values for each marking. Now plotting the polar graph at proper scale is selected. Then a circle of diameter equal to 4 times the maximum reading of the dial indicator is drawn. It is done that we are assuming that the error is not more than the 4 times of the value shown by the dial indicator. Another concentric circle is drawn in this circle as shown in figure. The value of the dial indicator are plotted in the radial direction by taking the smallest circle as the reference circle. Means we will be taking the smallest circle perimeter as the 0 point. The individual points are joined by straight lines to get the actual profile of the workpiece as shown in figure. Then we can have the actual profile of the workpiece. Now, error is measured as the radial distance between the maximum and minimum inscribing circle for the profile obtained. That is, roundness error is equal to measured error from polar graph divided by K, where K is a constant which depends on the shape of the workpiece and angle of V block. The position of indicating instrument, the number of lobes on the workpiece and the angle of the V block have an influence on the determination of roundness error. Means more the number of demarcation, the more will be the accurate results. Now second is roundness measuring machine. This machine is also called as teleround instrument or precision spindle method. The main part of the instruments are a truly running spindle that is mounted on precision ball bearing and micron indicator. The indicating pointer is rotated around the workpiece about an accurately stable axis as shown in figure. Then the indicator shows deviation from roundness. As the output of the indicator is connected to an amplifier unit and pen recorder, a polar graph of the output line of the workpiece is obtained. This method is an accurate method. Automatic recording of each exact profile of the workpiece obtained. Waviness also is superimposed on the profile of the workpiece. Okay, students.